This is how to determine if a precipitate forms. We are going to mix two solutions to give the following end concentrations below. My first choice is 0.03 millimolar Ki and 0.07 micromolar mercury nitrate. And we're sort of given the clue that mercury iodide might be the item that we're concerned about precipitating. All right. First, let me just write out the reaction that's going to occur. What we're doing is evaluating the solubility of mercury iodide, essentially. And if it dissolves, we have mercury 2+ and 2 iodide minuses. Okay, and that's in equilibrium. All right. Well, this is a situation where we should compare Q to K. All right. We know K's value. K is 2.9 times 10 to the minus 29. Q is going to be equal to our mercury concentration times our iodide concentration squared. So our mercury is 0.07 micromolar. So that is going to be 0.07, and then a micromolar is 10 to the minus 6th molar. So I'm going to get this in units of molar, okay? That's what micro means, all right? And then my iodide is 0.03 millimolar, so that's 0.03, and that, if I get it into molar, is 10 to the minus 3, and I need to square that. So that becomes 6.3 times 10 to the minus 17. Okay, let's evaluate K versus Q. Q is much larger, okay? That means we've made too much product. So this reaction is going to shift to the left side. And what is on the left side? Solid, okay? So in this case, solid, or we also know that as a precipitate, forms. Okay, let's take on the next one. We have 0.6 micromolar silver nitrate and 0.7 micromolar sodium bromide when we do the mixing. Once again, I'll write down the equation that we're evaluating. We're taking silver bromide and we're evaluating the equilibrium between silver plus aqueous and bromide minus aqueous. Alright, my K value is given to me. That is going to be equal to 5.0 times 10 to the minus 13. My Q I need to evaluate. My Q is going to be equal to my silver times bromide. So that will be equal to, let's see, what do we have? Silver. 0.6 times 10 to the minus 6, because that's micromolar, molar, and 0.7 also times 10 to the minus 6th. And I will multiply that out. And the value I get is 4.2 times 10 to the minus 13. Okay, once again, let's compare K to Q. This time K is bigger than Q. So this means the reaction shifts to the right. And what do we have on the right side? Aqueous materials. So this one would be no precipitate forms. And that's how you do that.